Good day to you all. I am C.S. Srinivasarao, Associate Professor, SVKP and Dr. K.S. Raja Arts and Science College, Perigonda. I welcome you for the class File System Implementation. In this File System Implementation, we discuss two topics. One is the allocation methods, file allocation methods, and second one is the free space management. These are the two topics discussed in this class. First one is allocation methods. There are three file allocation methods. One is the continuous allocation method, second one is the linked allocation method, third one is the indexed allocation methods. These are the three allocation methods. File allocation methods are three: continuous, linked, and indexed. First, continuous allocation method. Each file occupies a set of continuous blocks on the disk. Continuous blocks on the disk. File, it contains the continuous blocks. The file can be stored in the disk with a set of continuous blocks. And this continuous allocation method is the simple because it has only starting location, the starting block number, and the total number of blocks that represented with length. The start and length, these are the two values we require for the file. So that's why this continuous allocation method is simple. Now the problem is wasteful of space. That means the dynamic storage allocation problem. See the diagram. This is the continuous allocation of disk space. This is the disk and these are the block numbers. These block numbers are 0 to 31, totally 32 blocks. Now see the shaded part, 0, 1. These are the two blocks for the count file. Now the directory, it contains the file name, starting block of the file, and length, total number of blocks. For example, if you take the count is the one file, tr is the second file, mail is the third file, list is the fourth, and f is the last file. For example, if you take the count is the one file. The starting block of the count file is 0, and from there to the length is 2 means 2 blocks. These 2 blocks represents the count file. And tr is the one more file. The starting block of this tr file is the 14. From 14 to the length is 3 means 14, 15, 16. These are the 3 blocks represents the file tr. Like that, mail, list, and f. Now after occupying all these 5 files, what are the free blocks here? Just you verify the 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, 19, 25, 26, 27. These are the free blocks. Total blocks are 2, 4, 8, 10, 11, 12, 13, 14, 15. 15 blocks are free. This represents the 15 blocks are free. Suppose if you want to store, if you want to create the one more file. So for example, the test is the one file. Test is the one file. It requires 7 blocks. 7 blocks. The size of that file is 7 blocks. Just you verify the 7 continuous blocks in the file. Totally 15 blocks are there, but you verify 7 continuous blocks. Here the longest continuous blocks is 1, 2, 3, 4, 5, 6. 6 blocks are there. So if you require the 7 continuous blocks, that is not possible. Total free blocks are 15, even though you can't store the particular test file with the length is 7 blocks. That is the problem with the continuous allocation disk space. Now the second one is linked allocation. Thus in the linked allocation method, the each file is linked list. So it maintains the one linked list of disk blocks. This is the linked list of disk blocks, and blocks may be scattered anywhere. That is not in the continuous. The blocks can be scattered anywhere on the disk. That is by using the block is by using this is the logical view of the block structure. Just you check the logical view. This is the linked allocation. The same concept 0 to 31. These are the blocks. Now you check the directory. Zip is the one file. Zip is the one file. Under this linked allocation, it specifies the starting block 9. Instead of length, it specifies the 25th is the ending block number. So starting block number is 9, ending block is 25. It maintains the one linked list. That means you go for the 9. This is the 9. From 9 to one more link, you can go to the 16. From 16 to 1, 1 to 2, 1 to 10, 10 to 25. 25 is the last, and minus 1 represents the particular end of the file. So this is the way this maintains the linked list. From 9 to, this is the head node 9, 9 to 16, 16 to 1, 1 to 10, 10 to 25. This is the linked list. The last node. In the directory there are two things, start and end. Instead of the size, this specifies the end block number, right? This is the linked allocation method. Third method, the file allocation table like directory. This is the test is the name, and starting block 217. You go to 217. 217 points to the 618. This is the link pointer to the 618. 618 is again points to the 339. This is the 339 is the last generally. This is the file allocation table under the linked allocation table. Now the third allocation method is the indexed allocation method. Under this, it brings all pointers together into the one index block. The logical view is this one. This is the one index block. This points to the all blocks of that one. The structure, see the structure. Example of indexed allocation. The same disk 0 to 31. You take the zip file. So it has the only one value, indexed block. 19 is the indexed block. This 19 is the indexed block. So from this 19, you can access the 9. The pointer you see the from 19 to 9 and 16, 1. This is the 1. 10 from this to 10 and 25. 25 is the last. These are the next blocks occupied by the zip file. So the total blocks are 19 is the index block, and the data content is stored in these 5 blocks 9, 16, 1, 10, 25. 25 is the last block. This is the example of indexed allocation, 3 allocation, continuous, linked allocation and indexed allocation. That is the first topic. Now the second topic is free space management. Whenever you create the one file, the file must be stored in the disk. Before storing the file, you must find the space within the disk, the free space. The free space management. This is called free space management. The file system can maintain this. Any file system can maintain the free disk space to store the newly created files. So we require the amount of space at the time of file creation. So the file system allocates the required amount of space from this free space, because it maintains the number of free blocks in the disk. From that free blocks, you can allocate the space for the file at the time of file creation. At the time of file creation, you have to allocate the space from free space list. And whenever you delete the file, you remove the particular space occupied by the particular file and add the particular removed space into the free space list for the next newly created files. That is called remove the space. At the time of remove the space and add it to free space list at the time of file deletion. At the time of file creation, allocate the amount of space, required amount of space from free space. At the time of file deletion, remove that space and added it to free space list. And there are 3 techniques we use to maintain the free space. One is the bit vector or the bit table, and second one is the chain free points or linked free space list. Third one is the index block list. These are the 3 techniques to maintain the free space list. Free space list is for the files management. One is the first method is bit vector. This is the array of bits. The 0 to n minus 1, the total n number of bits. Each bit value can be either the Boolean value, that can be either the 0 or 1. 0 means the particular block is free. 1 means the block is occupied by some file. For example, here is 0 means the block number 2 is free. Here is 1 means the block number 1 is occupied by some file. That represents the bit vector, represents whether the block is free or occupied by file. Just you check it. Bit vector is a collection of bits, represents block status. This is the bit vector, represents either 1 or 0. 1 means occupied by file, 0 means that is a free block. If the block is free, the bit is 0, and bit is 1 represents block is allocated. Now you check 1, 2, 3, 4. First 4 ones represents 4 blocks are occupied by some file. 5th block value is 0 means the 5th block is free. 8th block is free. 16th block, 35, 40, 43, 48, 51. How many blocks are free here? Number of zeros. 1, 2, 3, 4, 5, 6, 7, 8. 8 zeros are there. That means 8 these 8 blocks are free. That is the first mechanism. The technique is bit vector. Second, linked free space list. This is it keeps a pointer to the first free block. Just it gives the first free block that points to the first free block, which then points to the next free block like a chain of free blocks. This is much like a linked list. First free space, that is the fifth block, is the first free space block, and the next free space block is a pointer from 5 to 8. 8 is the next free block, and that 8 points to the next free block, that is the 16th. 16th is next free block. Like that, this is the chain of free blocks. All the free blocks are pointed by this particular, that is represented by linked list. That's why this is called linked free space list. Third method is indexed block list. This stores the address of n free blocks. Address of n free blocks in the first free block. Just you take the one first free block. For that first free block, it contains the n free blocks. This is the one free block. The 36 is the free block. It contains the n free blocks. So 10 is the 36 represents the total free blocks under this 36. So those free blocks are called 10, 15, 46, like that. So this is the represents first free block is the 36. Whereas only it has n minus 1 free blocks. The last 50, this is the pointer to the next index block. This is the next index block. 50 is the next index block. That 50 is the next, that index block contains the next free blocks. This is 54 is the free block. 38 is the free block, another free block. 60 is the another free block, and the last free block is 28. So here the index block list that specifies the only first index block, that is called 36. That 36 contains the free blocks. 10 is the free block, 15 is the free block, 46 is the free block. Whereas 50 is index block that points to another index. That index block contains the free blocks. This is the chain of index blocks. This is called the indexed block list. So here it stores the address of n free blocks in the first free block, where n minus 1 are actual free blocks. See that 36 it contains the 4 free blocks, where n is the 4, but only free blocks are 3, n minus 1 3, 10, 15, 46. These are the 3 free blocks. N minus 1 are actual free blocks. The last one is the disk address of another block. The last one means 50 is the disk address of another block that containing the another address of another n free blocks. This 50, it contains the address of another n blocks, another 4 free blocks. 54, 38, 60 and 28 are the free blocks. This is about the indexed block. So end of the file system implementation. Thank you one and all.